Welcome back. Let us go through the question first. A boy standing on a stationary lift, which is open from the above, throws a ball upwards with the maximum initial speed he can. In this case, it's equal to 49 meters per second. How much time does the ball take to return to his hands? If the lift starts moving up with a uniform speed of 5 meters per second, and the boy again throws the ball up with the maximum speed he can, how long does the ball take to return to his hands? So let us now consider the upward direction to be positive. It's really important to begin any solution uh, which is of this kind. So the initial velocity of the ball which is given is 49 meters per second. The speed of the ball will be the same when it reaches the boy's hand, but will be moving in a downward direction. Therefore, the final velocity would be minus 49 meters per second. So you can see the magnitude is same as this 49 meters per second, but here in case of the second one the sign is negative, and the acceleration is the value of g, which is minus 9.8 meter per second square because of the direction. So using the first equation of motion, we have v equals to u plus at, and we can find out the value of t using this formula. We already know value of v, value of u, and value of a. So calculating, we get t equals 10 seconds. And in the second case, as the ball has been thrown after the lift has started moving upwards with a constant velocity, the relative velocity of the ball with respect to the boy remains the same, and therefore the ball will again take 10 seconds to reach the boy's hands. Hope it's clear to you. See you in the next one.